All right, welcome back to Chapter 5, Section 6, I believe. I think we had a little bit of a technical issue there. Let's see. Yeah, example 5. Okay, good. So on example 6, all right, so example 6 kind of runs exact same as the previous problem. So we need to remember that we're going to do distance equals rate times time. So we got distance is equal to rate times time, and then we're going to go from there. Okay, so this particular problem, Valentina travels 70 kilometers to Rome by train and then takes a bus 30 kilometers to the Colosseum. Sorry about that. The bus travels 24 kilometers per hour slower than the train. If the total time traveling on the bus and train is 2 hours, find the average speed of the train and the average speed of the bus. Okay, so this particular problem looks like we are given, again, we're given the distance as well as the rate. Okay, so we're given both the distance and the rate again, so we're going to have a problem just like the last one where we have time is equal to the distance. Let's just put it like this: distance divided by rate. Okay, so um, setting this problem up, we'll go ahead and do that. We'll do the train first, then the bus, and then this total. Let's do total. I'll erase that. It's no big deal. I'm just gonna set this problem up. All right. So my total time on the train, right? If my distance on the train, travel on the train was 70 kilometers. Actually, I'll go and keep that. 70 kilometers. And my rate on the train was, well, I don't know. Okay, so we don't know my rate on the train. That's fine. Plus, well, what's my speed? I'm sorry, my distance on the bus. Well, that was 30 kilometers. All right, and then my rate. Well, again, I don't know my rate, but I do know that it was 24 kilometers slower than than on the train. And if my train speed was x, then 24 miles, or I'm sorry, I keep saying miles, then 24 kilometers an hour slower on the train or on the bus is going to look like this. Okay, and again, I'm setting this particular problem up just with distance over r, right? D over r, D over r. That's all I did, using my distance equals rate times time. And then my total time was 2 hours. Okay, and then from here, we just simply solve this particular problem. So let's go ahead and solve it. Okay, what was my least common denominator here? Well, that's not bad. Okay, so my least common denominator, I thought it was going to be worse than it was. It's actually just simply x times x minus 24. So I'm going to multiply this entire problem by x times x minus 24. So if I distribute over here, right, it looks like just the x's cancel. So I'm going to have a 70 times x minus 24. And then plus, I distribute here. My x minus 24 is canceled, so I've got 30x plus 30x. And then is equal to, well, this is just going to be just one big giant mess here. It's going to be 2x times x minus 24. All right, so let's go ahead and distribute on the left side here. 70x, and then 70 times 24. Well, 70 times 10 is 700. 70 times 20 is 1400. 70 times 4 is 280. So we're going to say it's minus 1680. Plus 30x is equal to a 2x squared minus 24. I'm sorry, minus 48x. All right, now we're going to combine all of my like terms here. So we're going to combine everything and just go ahead and put it on the left side here, okay? So we're going to have a 0 on the left. I'm sorry, we're going to put everything on the right side. Sorry, put everything on the right side. So my 2x squared, that's nothing combines with that, okay? I've got a 70x and a 30x, right? And that makes 100x, but I'm going to subtract that 100x. So negative 48x minus 100x is negative 148x, so minus 148x. And then I'm going to have, looks like I'm just going to add 1680 plus 1680. Okay, now this looks like a big old mess, and that's because it is, but first thing I'm going to do, it looks like I can factor a 2 out. So let's try to make things a little bit easier. So factor 2 out, I've got x squared. Half of 148 was 74, so minus 74x, and then half of 1600 looks like 840. Okay. Well, 840. Hang on a second. So 0 is equal to, and then this factors in 2. 60 and 14. So x minus 60, x minus 14. So this tells me that my solution here is x is equal to 60 and that x is equal to 14. Okay. So it's kind of weird. Okay, so looking at this particular problem, 60. Oh, I guess, yeah, I guess it could be both of those. Okay, so if I'm traveling, let me check real quick. Yeah, okay. So we're gonna check both of these. Okay, so one of my solutions was a 60, and one of them was a 14. Okay, so if I plug them in to my equation here, all right, let's try it. Let's do 60, right? 70 over 60, that makes sense. 60 minus 24, that makes sense, right? 60 minus 24, well, that's just going to be, sorry, 36, okay? So that makes sense. However, the others, oh no, the other solution was, oh crap, well, the 60 is just going to stay. We'll make it a 4. Let's put, yeah, dang it. I forgot that I got to upload these notes, so we'll erase this. And this was an x, and this was an x, okay? So 60 works, right? However, 14, okay, so if I plugged in a 14 here, that's okay, but a 14 here, okay, it's 14 minus 24 is a negative 10. Now, if you recall, this particular ratio here is the my rate or I'm sorry, my time on the bus, right? And the denominator especially was how fast I'm going. Okay. Well, when we talk about speeds, right, we don't want to say negative 14 or in this case negative 10 miles per hour, right? So we're not going to say negative 10 miles per hour. So if that's the case, then my solution here is just going to be the x equals to 60 because I'm not traveling at a negative speed on the bus. Okay, so hopefully that made sense. If not, maybe the textbook can word it better than I just did. Okay, so if x equals 14, then the rate of the bus would be negative 10. Because a negative rate of negative 10 kilometers per hour is not reasonable, I guess not reasonable is good, we reject x equals 14. Therefore, the solution x equals 60. That is, the average rate of the train is 60 kilometers per hour, and the average rate of the bus is 36 kilometers an hour. So yeah, since it is not reasonable, it's not a reasonable solution, then we can indeed reject it. Okay. And then lastly, we're going to talk about work. So you're going to, so many of you, I'm assuming, are probably going to be, I don't say many, but some of you are probably going to be going to college after college, right? You're going to be going to probably graduate school. Well, one of the problems that is posed in graduate school is a work problem like this, right? And they're super duper easy to do if you know the secret, right? So let's go ahead and read this. So it reads, Joanne can wallpaper a bathroom in 3 hours. Bonnie can wallpaper the same bathroom in 5 hours. How long would it take if they worked together? Okay. Now I don't think it actually gives us the total. It might in the next section. I don't know. But all you have to do basically is just say 1 over time for work 1 plus 1 over the time for worker 2, and that's going to be equal to 1 over the total time. Okay, if you do this, it's going to be so easy for you. All right, so well, let's do it like that. Okay, and actually let's put this in yellow. I like to put those little tidbits in yellow like that. So 1 over worker 1 plus 1 over worker 2 is equal to 1 over the total time. Okay, which makes sense because um, well, because they're ratios essentially, right? If you can just kind of get into no, let's not do that. Okay, so anyways, we'll say Joanne. So Joanne does it in 3 hours. So put 3 down there. Plus Bonnie does it in 5 hours. Okay, so 5 down here. All right, how long would it take for them if they work together? So it'd be 1 over, question mark there. We don't know. All right, so we'll just put an X there, okay? Because we don't know. That's the unknown. And that's it. That's all. That's all you have to do. And I'm actually going to leave this just like this because I want you to explore this on your own. It's really easy, and once you get it, I feel like you'll have a great aha moment. But anyways, that does conclude today's lecture and the second video of today's lecture.